Hi class, today we have a video on Swun 2-2. This is factor pairs with prime and composite numbers. So yesterday we learned that a prime number is any number that has the factors of just 1 and itself. And we learned that a composite number is any number that has more than two factor pairs. So our learning objective is today I will find factor pairs for whole numbers and determine if they are prime or composite numbers. So we're still working on a similar learning objective. We have some similar vocabulary words. So the first one is multiple. Multiple is the product of a number and any other whole number. So for example, if I have 24 equals to 4 times 6, the product or the multiple is 24. So that's our product slash multiple. Okay. And then the 4 and 6, that's what we learned yesterday, are called factors. Those are the two numbers getting multiplied together. So the two numbers getting multiplied together are factors, and then your answer is a product or multiple. Our next vocabulary word is factor pair. A factor pair are two numbers, and in parentheses it says factors, so we know that those two numbers are getting multiplied together, that produce a product or multiple when multiplied. Okay, so for example, if I have the number 24, my factor pairs for 24 are 1 times 24, 2 times 12, 3 times 8, 4 times 6. All of these are factor pairs for the number 12. And because there's more than just 1 times 24, that means that this is going to be a composite number. Okay, our next vocabulary word is first 20 prime numbers. So these numbers, you can only multiply it 1 times 2 to get to 2. Only 1 times 3 to get to 3. For all of these numbers, this is a good place to look if it's asking questions about prime numbers. Okay, we have some new notes. So these notes follow that divisibility rule video that I made, that extension video, and it's just a shortened version. So the divisibility rule for 2 is if it is even, meaning if it ends in a 0, 2, 4, 6, or 8, then it can be divided evenly by 2. And I'm just going to show you an example. So if I have the number 2, I'm looking in the ones place, that digit ends in a 2, it is even, so I can evenly divide 12 by 2 and get 6. Okay. 3. The sum of the digits is divisible by 3. And remember, sum is adding. So if I have the number 12 and I add the digits together, 1 plus 2 equals to 3. And I know I can do 3 times 1. So 3 times 1 equals to 3. So that means that 12 can be divided by 3, which equals to 4. Okay, the next one. The rule for 4 is the last two digits are divisible by 4. So if I have the number 112, 12 is my last two digits, and I know 3 times 4 is 12, that means that 112 divided by 4 would work because 12 divided by 4 equals to 3. The next one is for 5. 5 says that it has to end in a 0 or 5. So I have the number 12. I look here, it does not end in a 0 or 5, so 12 is not divisible by 5. However, the number 10 ends in a 0, so I can divide 10 by 5 and get 2. Number 6, it is divisible by both 2 and 3. So I have to refer back to rule 2 and rule 3. So if I have this number 12, I just keep using 12. So 12 ends in a 2, so it works. And 12, I can add the two numbers up, which gets me 1 plus 2 gets me 3, which shows me that 3 can be divided. 3 times 4 equals to 12, so that gets me to 12, so 6 would work for 12. And if I wanted to check, I could do 12 divided by 6 equals to 2. Okay, 7, there is no rule, unfortunately. 8 is very similar to 6. We have to see if it's divisible both by 2 and 4, so we refer back to those two numbers. So I'm going to look at the number 24. So 24 ends in an even number, so it would work for 2. And then the last two digits are divisible by 4. So can I divide 24 by 4? I can, and I get 6. So that means that 24 divided by 8 will work, and that will get me 3. Okay, number 9, the sum of the digits is divisible by 9. So if I have this number 81, I can add 8 plus 1, and I get 9. I know 9 is divisible by 9. That gets me 1. So I know 81 divided by 9 equals to 9. And then 10, it has to end in a 0. So if I have the number 23, it ends in a 3, does not end in a 0. It is not divisible by 10. But I know the number 100 ends in 0, so it is divisible by 10. Okay, I am getting out my steps. Sorry, this is a little bit of a longer video. Step number 1 says write the multiple. And remember, that word multiple is the same thing as product. So write the multiple. Step number 2, begin with 1 and work systematically to find factors that equal the number. And when I mean systematically, I mean just count. Go in order. So let's put go in order. And then step number 3 is write the pairs. I'm getting out my red pen so you get a chance to pause, to watch. Our first problem for my input is find the factor pairs for 24. So step number 1 says write the multiple. So my multiple is 24. Step number 2 is begin with 1 and work systematically to find the factors that equal the number. Have to go in order. 1 times 24, 2. I know 2 has to work because I refer back to these rules and it's even. So 2 times 12 equals 24. 3. I'm just going to refer back to my rule. Does 3 work? I have to add the digits. So 2 plus 4. 2 plus 4 is 6, so it should work. So 3 times 8 equals to 24. Now let's see the rule for 4. 4. The last two digits are divisible by 4. I just have to know my facts for that one. So 4 times 6 is 24. I'm going to try 5. Ends in a 0 or 5. It does not end in a 0 or 5, so that doesn't work. 6, I'm going to stop. I'm at a repeat, so I don't need to go any further. That's what I mean by systematically. Count your way up, 1, 2, 3, 4, and then stop when you're at a repeat. Okay. Step number 3, write the pairs, which we did. So here are our pairs. And then I have to answer this question. Find two composite numbers that would make this equation true. So I'm looking here and I see 4 and 6. Those both are composite. There's more than just 1 times 4 equals to 4, because I know 2 times 2 equals to 4. And 2 times 3 equals to 6. So 4 and 6 make this sentence true. Okay, second problem, find the factor pairs for 39. So step number 1, write the multiple. So 39 is my multiple. Step number 2, begin with 1 and work systematically, so go in order, to find the pairs, and I'm going to write the pairs as we go. And I'm going to use these rules again to help me. So 1 times 39 works. 2, I look at the rule for 2. Is it even? It is not even, so 2 doesn't work. 3, let's look at the rule for 3. The sum of the digits is divided by 3. So 3 plus 9 equals to 12, so it will work. So 3 times 13. 4, let's see. 4, the last 2 digits are divisible by 4. I've never heard of anything 4 times a number to get to 39, because I know 4 times 10 is 40. So 39 wouldn't work. So 4 isn't it? 5. Let's check the rule for 5. Ends in a 0 or 5. It ends in a 9, so 5 doesn't work. 6. It's divisible both by 2 and 3. I'm looking here and I crossed off 2, so 6 won't work. 7. 7's not going to work. 8. It is divisible both by 2 and 4. It's not divisible by 2, so 8 doesn't work. 9, let's see. So 9 is the sum of the digits is divisible by 9. So 3 plus 9 equals to 12. I can't fit a 9 inside of 12 evenly, so 9 would not work. 10 does not work because it does not end in a 0. 11's not going to work. I'm finding that I'm getting to a repeat. I'm back at 13, so I'm going to stop. My factor pairs for 39 are 1 times 39 and 3 times 13. So this question says find 2 prime numbers that would make this equation true. 39 is not prime, so I cannot use 1 and 39. The triangle would have to be 3 and the circle would have to be 13. Okay, I'm getting out my green pen so you are following along again. Okay, step number 1, write the multiple. So our multiple is 36, so let's write 36. Begin with 1, and we're going in order. 1 times 36, 2. Let's look at our rule. Is it even? It is even, so I can multiply 2 times 18. 3, let's see what the rule is. The sum of the digits is divisible by 3. So I have 3 plus 6 is 9. It is divisible. So 3 times 12. 4. Let's see. The last 2 digits are divisible by 4. That is true. 4 times 9 is 36. Let's try 5. 5 times, it ends in a 0, 5. This one does not, so 5 would not work. 6. If it's divisible both by 2 and 3. I look here, it's divisible by both 2 and 3, so 6 would work. 6 times 6. I'm going to stop because I'm at a repeat. So here are the factor pairs, and then I need to find 2 composite numbers that would make this equation true. Again, not prime numbers. I can see 4 and 9 would work. So let's do 4 and 9. Okay, second problem, find the factor pairs for 22. Step number 1, write down that multiple. Step number 2, you start with 1 and you work systematically. So 1 times 22. 2, I know this one's even, so 2 has to work. 2 times 11. 3. The rule for it is add the two numbers, so 2 plus 2 is 4. I can't divide 4 by 3, so that wouldn't work. 4. The last two digits are divisible by 4. I know 4 times 5 is 20, and I know 4 times 6 is 24, so that doesn't work. 5. 5, it has to end in a 0 or 5. It does not end in a 0 or 5, so 5 doesn't work. 6. 6 times 3 is 18. 6 times, oh, let's look at our rule before I start thinking too hard. It is divisible both by 2 and 3. It's not divisible by 3, so that does not work. 7 doesn't work because I know 7 times 3 is 21, and this is 22. And then 8. 8 does not work because it is not divisible by 4. Okay, 9. 9's not going to work because I know the sum of the digits is 4. That does not divide by 9. And then 10 doesn't work because it is it doesn't end in a 0. So I'm at a repeat with 2 times 11. So here are my factor pairs, and I need to find two prime numbers. So 2 and 11. Let's go back to our prime number list. So 2 and 11 are both prime numbers, so that would work. 2 and 11. Okay, you have 2 homework problems, and rate your understanding. Have a wonderful evening.